For our next hypothesis, we're hypothesizing that there will be a main effect for time of day, such that students who are in the 9 a.m. class have higher grades than students in the 3 p.m. class. We're also hypothesizing a time of day by seating location interaction, such that in the 9 o'clock class, students in the front will have higher grades than students in the back. In the 3 o'clock class, students in the back will have higher grades than students in the front. So to be clear, we're hypothesizing a main effect of time of day, no main effect for seating location, and an interaction between time of day and seating location. And again, my advice is start by trying to make sense of the interaction and then factor in the main effect that you have to deal with. Right? So the interaction is at 9 o'clock, students in the front will have higher grades than students in the back. So make sure you represent that in the graph. But at 3 o'clock, students in the back will have higher grades than students in the front. The trick here is you have to know that your graph has to also represent that there's not a main effect of seating location. So the key here is that the students in the front on average have to be the same as the students in the back on average. If you fail to factor that part in, your graph's not going to look right. Okay? So take a moment, pause the video, try to make sense of this graph. Try to graph out the line graph and the bar graph. All right, so hopefully you try this to graph this out. So what you see here is we have a main effect of time of day, right? So the average of our 9 o'clocks, if I'm just kind of eyeballing it, is about 75. The average of our 3 o'clocks is about 55, right? So there's a clear main effect of time of day, such that the 9 o'clock class did better than the 3 o'clock class. Let's look at if there's a main effect of seating location. So we're taking the average of our fronts, right? So the average of 85 and 45, which is 65, which is here, which is exactly the same as the average of our backs. So good, there's no main effect of seating location, which is what we needed. Now the question is there an interaction between the two? And we can say yes, because at 9 o'clock, students in the front did better than students in the back. But at 3 o'clock, students in the back did better than the students in the front. So one way to think about interaction is, well, there's two ways to think about it that I think help students kind of understand it. When you graph it, you want to be able to see, does the pattern of the means change from one level of the independent variable to another? So if we're going from 9 o'clock to 3 o'clock, does the pattern of our means change? And it's clear in this example that they do, right? So at 9 o'clock, front is doing better than back, right? That's the initial pattern of the means. Front is doing better than back. But at 3 o'clock, the patterns flip. Now back is doing better than the front. Because the pattern changes, now you know you have an interaction. Another way to think about interaction, there's two ways you can get interaction. One was with the patterns change. Another is the patterns stay the same. So the pattern is, say, for 9 o'clock, front's doing better than back. At 3 o'clock, front is still doing better than back. But you might find that the magnitude of the difference between front and back is different from 9 o'clock to 3 o'clock. So let's say at 9 o'clock, the difference is relatively small between front and back, right? Maybe it's like 10 points. But at 3 o'clock, it's huge. It's like 40 points, right? It's the same pattern where front's doing better than back, but now there's a bigger difference between fronts and backs. 9 o'clock, the difference is relatively small. At 3 o'clock, it's large. So if you either have a change in the pattern of means or a change in the magnitude of the effect, even though the pattern does not change, those will both indicate that you have an interaction. So if you do a bar graph, again, you can see the patterns are changing. At 9 o'clock, front's doing better than back. At 3 o'clock, back is better than front. The average of our backs and fronts are the same. And you clearly can see that you have a main effect time of day. 9 o'clock is better than 3 o'clock. You also have the interaction where the pattern changes from 9 o'clock to 3 o'clock. So for our second to last hypothesis, we are arguing there's going to be a main effect of seating location and an interaction between seating location and time of day. So specifically, I hypothesize that there'll be a main effect for seating location such that students who are in the front will have higher grades than students in the back. I also hypothesize a time of day by seating location interaction such that for students in the 9 o'clock class, the location will have no effect on grades, but at 3 o'clock, in the 3 o'clock class, students in the front will have higher grades than students in the back. All right, so again, you got to factor in the interaction first, then address the main effect that we have hypothesized, ensuring that you also do not have a graph that would represent that we have the other main effect. The graph has to show that there's no main effect for time of day. Pause the video, see if you can graph this. So it should look like this, right? So this indicates that there is a main effect of seating location. The average of our fronts, right? The average of about 65 and 85 or 75, that's higher than the average of our backs, which is about 65 and 45, so 55. So there's a difference there. The averages are in the front is higher than the average in the back. There's no main effect of time of day. So the average of our 9 o'clocks is about 65. The average of our 3 o'clocks is 85 and 45, which is also, if you average it, that's 65. So good. So now we didn't show the main effect of time of day because there isn't one. And we have an interaction, right? So at 9 o'clock, the means are the same. At 3 o'clock, those in the front are higher than those in the back. Then our bar graphs, again, 9 o'clocks are the same. 3 o'clock, front is higher than back. There's a main effect of seating location, just the average of the fronts, the average of the two reds. It's higher than the average of the backs, which is the average of our two blues. There's no main effect of time of day because the average of 9 o'clocks is 65. The average of the 3 o'clocks is also 65. All right, our last one. I hypothesize a time of day by seating location interaction such that in the 9 o'clock class, students in the front will have higher grades than students in the back, but in the 3 o'clock class, students in the back will have higher grades than students in the front. So we're hypothesizing no main effects, but an interaction between time of day and seating location. And this particular interaction, when you have no main effects but you have an interaction, is called a crossover interaction. So take a moment, try to graph this out. Remember, you try to graph it, making sure that you have the interaction, but you don't have either of the main effects. The graph should not show any main effects, but it should show the interaction. So if you do a line graph, it should look like this. It's called a crossover interaction because the lines literally cross each other like this. So as you can see, there's no main effect of seating location. The average of the fronts is the same as the average of the backs. There's no main effect of time of day. The average of the 9 o'clocks is the same as the average of the 3 o'clocks. But there is an interaction. At 9 o'clock, students in the front do better than students in the back. At 3 o'clock, students in the back do better than students in the front. So the pattern of the means changed from 9 o'clock to 3 o'clock. That's where the interaction is. If you have a bar graph, again, there's no main effects, but there's this interaction. At 9 o'clock, students in the front are doing better than students in the back. At 3 o'clock, students in the back are doing better than students in the front. Now, when you're interpreting main effects with interactions, you should focus primarily on the interaction, not the main effect. You should report the main effects and the interaction, but you should use the interaction to interpret the results. Because ultimately, the main effects are being driven by the interaction. The interaction is where all the action is. The main effects are just kind of being influenced by the fact that you have that interaction. So if you have main effects with an interaction, focus on interpreting the interaction. You report everything. You report that you had main effects and that you had interaction, but when you're trying to make sense of the results, you focus on trying to interpret the interaction.